Hi, in today's video, let's do a revision on the chapter of Organic Chemistry. So I've chosen a question from O-Level Science Chemistry 2017 Paper 3 Question 10. Let us first have a look at the question. Part A. Describe the process and conditions by which alkenes are manufactured from long-chain hydrocarbons. A chemical equation is not required. Alright, so for this question is a theory question. Let me phrase it down for you. We can first copy the question by saying alkenes are manufactured. Alright, alkenes are manufactured from long-chain hydrocarbon right by catalytic cracking. So this is a keyword, catalytic cracking, where long-chain hydrocarbon are passed over aluminium oxide at 600 degrees Celsius. Alright, this produces smaller molecules of alkenes and alkenes. Alright, so this is the phrasing for our part A question. Alright, part B. Ethene is an alkene. Suggest using a dot and cross diagram the electronic structure of ethene. So there's a C2H4. Alright, so I'm gonna write this here, B. C2H4. Alright, so first of all, we will draw two carbon in the middle. Alright. And then there's 4 hydrogens. Because of the electron repulsion, so we have to draw them as far apart as possible. So for the carbon, there's a double bond, so there will be 2 pairs of electrons in the middle, whereas the hydrogen is a pair of electrons that's being shared by the hydrogen and the carbon. Alright, so remember to write your key. The crosses are electrons from carbon, whereby the dot are electrons from hydrogen. Alright, so this will be it. Okay. Part CI. Alkenes burns in oxygen. Write a balanced chemical equation for the complete combustion of any alkene. So let us choose ethene. Okay, I'll write this right here. Ethene have the chemical formula of C2H4, and if we react with oxygen, there is a combustion reaction, right? It gives the carbon will burn to give carbon dioxide, while the hydrogen will form water. Alright, so we have to balance this up. There's 2 carbon, so we'll need 2 of these. 4 hydrogens, so we'll need 2 of these as well. This will give us a total of 4 oxygen and 6 oxygen. So we'll need 3 of these. Alright, so this is the equation. Alright, so part 2. Use your equation to determine the volume of gas formed at room temperature and pressure when 100 cm³ of the alkene burns completely in oxygen. Alright, so we have 100 cm³ of alkene. That means we have 100 cm³ of this. Okay, first of all, let us look at the what's that? Volume of gas formed. So volume of gas formed, that will be the carbon dioxide. So we can do a mole ratio of ethene and carbon dioxide. So that is a C2H4 is to carbon dioxide. This is a 1:2. So we have 1:2. Okay. If we recall the formula of the mole for gaseous product, is actually mole equals to volume divided by molar volume. So if you can understand, since the molar volume is a constant at 24 dm³, the mole ratio will be equals to the volume ratio as well. Okay, so we can actually use 100 cm³ right here. So if we burn 100 cm³ of the ethene, we will get 200 cm³ of the carbon dioxide being produced. Alright, so this will be the answer for our C part 2.